Hi guys, welcome back to our discussion on infinite series. Our topic for today is about alternating series. So before we start, let us discuss the objectives of the study. So at the end of this lesson, you should be able to use the alternating series test to determine whether an infinite series converge. Okay, but what is alternating series? An alternating series is a series whose terms alternate between positive and negative, and it is one of these forms. Now, so number one, the summation of negative 1 raised to k plus 1 times a sub k, where k is from 1 to infinity. That if the value of k is 1, then this is 1 plus 1 or 2, and negative 1 to the second power is positive, and then times a sub 1. So we have a sub 1 as the first term. If k is equal to 2, then you have 2 plus 1 is 3, and negative 1 raised to 3 is negative times a sub 2. Plus, if k is 3, then you have 3 plus 1 is 4, and negative 1 to the fourth is positive 1 times a sub 3. So we have the third term of the series, and so on and so forth. Okay, the alternating series form is summation of negative 1 to the k times a sub k, where k is from 1 to infinity. If the value of k is 1, negative 1 raised to 1 times a sub 1 is negative a1. If k is 2, then negative 1 to the second is positive 1 times a2, so we have the second term. If k is 3, then you have negative 1 to the third is negative 1 times a sub 3. So that's the third term of the series, and so on and so forth. So to check whether the alternating series converge or diverge, we have to check whether the two conditions are satisfied. If these conditions are satisfied, then we can therefore conclude that the series converge. Okay, the first condition is that the terms of the series must be decreasing, meaning the first term must be greater than the second term must be greater than the third term, and so on and so forth. And then letter B, the limits of a sub k as k approaches positive infinity must be equal to 0. Okay, suppose we're given an example wherein we are asked to determine whether the given series converge. Okay, so because this is an alternating series, the sign is positive, negative, positive, negative. That if the value of k is 1, then you have negative 1 raised to 1 plus 1, so that's positive 1. And then this is 1 plus 1, so 2 over square root of 1 plus 1, so we have 2. If k is equal to 2, then you have 2 plus 1 is 3, and negative 1 raised to 3 is negative. Then you have 2 plus 1 over square root of 2 plus 1. Plus, if the value of k is 3, then you have 3 plus 1 is 4, but negative 1 to the fourth is positive. Then you have 3 plus 1 all over square root of 3 plus 1. If k is 4, then 4 plus 1 is 5, and negative 1 to the fifth power is negative. Then you have 4 plus 1 all over square root of 4 plus 1, plus, and so on and so forth. Then simplifying further, 2 over 2 is 1, 2 plus 1 is 3 all over square root of 2 plus 1, plus 3 plus 1 is 4 all over square root of 3 plus 1, minus 4 plus 1 is 5 over square root of 4 is 2 plus 1, so this must be 3. Then using calculator, we can observe that the first term is 1, the second term is 1.24, the third is 1.46, and the fourth term is 1.54. But if you can recall, the alternating series is said to be convergent if the terms of the series is decreasing and the limits of a sub k approaches 0. But because the terms of the series this is what increasing, so it fails to hold the first condition. So we can therefore conclude that the series diverge. Okay, another example. Suppose you're given the series summation of negative 1 to raised to k times natural log of k all over k, where k is from 3 to infinity. If the value of k is 3, then you have negative 1 to the third is negative. Then you have natural log of 3 all over 3 as the first term. Plus, if k is 4, negative 1 to the fourth is positive 1. Then we have natural log of 4 all over 4. Okay, plus if k is 5, then you have negative 1 to the p power is negative, then natural log of 5 all over 5, plus if k is 6, then negative 1 to the 6 is positive, times natural log of 6 all over 6, plus and so on and so forth. And then if you use your calculator, natural log of 3 all over 3 is 0.37, natural log of 4 all over 4 is 0.35, natural log of 5 all over 5 is 0.32, and natural log of 6 all over 6 is 0.30. So as you can see, the terms of the series is decreasing. This is greater than this, 0.35 is greater than 0.32, 0.32 is greater than 0.3. So the first condition is satisfied. For the second condition, we have to show that the limits of the n term or the kth term of the series as k approaches infinity is equal to 0. So to evaluate this, we replace k both in the numerator and denominator by infinity. So you have natural log of infinity all over infinity is indeterminate. So this is infinity over infinity. So for this type of indeterminate form, we can use the L'Hopital's rule. We differentiate separately the numerator over the derivative of the denominator. But the derivative of the numerator is 1 over k, derivative of the denominator is 1, so we have 1 over k. And then evaluating the limits of 1 over k as k approaches infinity, this is 1 over infinity or 0. So because the limits of natural log of k all over k as k approaches infinity is 0, and the terms of the series are decreasing, so we can therefore conclude that the series converge. So in summary, we can say that an alternating series is convergent if the two conditions are satisfied, that the terms of the series are decreasing, and letter B, the limits of a sub k as k approaches positive infinity is equal to 0.